We are given this function on the left side, f of x, in blue, and we are asked to draw a reciprocal function. I'm going to call that r of x, 1 over f of x. Recall, when you have reciprocal functions, you keep the x as is and you take the reciprocal of the y values. So let's start our analysis. Note, we are not given the equation, so we're just going to analyze the graph on the left and create the reciprocal graph on the right. The first thing we're going to do is locate the quote-unquote zeros, or the x-intercepts of the original graph. The word zero comes from where is the y value equal to 0. So the y value equals 0 here, the y value equals 0 there. So let's call this point 0, 0 on the original function, and let's call this point 4, 0 on the original function. When we move to the reciprocal graph, the x values are going to stay the same, and the y values are going to be flipped. So we're going to have 4, 1 over 0 and 0, 1 over 0. Folks, when we are graphing, and you're dividing by 0, those are vertical asymptotes. So this is telling us that on our reciprocal graph on the right, wherever x equals 0, we're going to have a vertical asymptote, and where x equals 4, we're going to have a vertical asymptote. So let's go ahead and draw those in on the reciprocal graph here, and let's call it here. And again, I'm estimating that that's x equals 4. Okay. The next thing we're going to do is we're going to locate what I call invariant points on the original graph. Let me write that word down. Invariant. Okay. The word invariant means it doesn't change. It doesn't vary. So let's look at the original graph. If we have an x value and we have a y value of 1, and then we move to the reciprocal graph and we keep the x value the same and we flip the y value, we're going to have 1 over 1, which is still 1. So in other words, folks, wherever the original graph has a y value of 1, whatever x value features a y value of 1, we're going to have the same exact point on the reciprocal graph. So let's identify the point, or in this case points, where our y value equals 1. So here's y equals 1. We see that about x equals -1, there's a point, -1, 1. And we also have x equals 1 about right here. Let's call that, just for argument's sake, 5, 1. Those points are going to be on this graph. Here's -1, 1. And here is 5, 1. Folks, those points are going to be very helpful as we put this graph together. Going on with the concept of invariant points. If we have on our original graph x, -1, and we move to the reciprocal graph, our x stays the same. We have 1 over -1. It's going to be the same exact point. So just like we did, we found the y value of +1. We're going to do the same thing with -1. So I'm going to say that this point here, where the y value is -1, is about x equals +1. So that's going to be x equals +1, y equals -1. And again, we have a second point right here. I'm going to call that x equals +3.5 and x equals -1. Folks, we're going to put these 2 points over here. We're going to have +1, -1 about right here, and we're going to have +3.5, -1 about right there. Okay, the next thing we're going to do, we have our vertical asymptotes, we have our invariant points plotted. The next thing we're going to do, folks, is we're going to look at the behavior of the original graph as we approach the zeros from both the left and the right. Okay, so let's go to the original graph. That's our first 0 at x equals 0. Let's look at what our graph is doing, what the y values are doing as it approaches the 0 at x equals 0 from the left. Okay, up here your y values are very, very big. Now they're getting smaller, smaller, smaller. So let's say your x value is 1, your y value is 1 here. As you approach, you're getting into fractions. So you're at, let's say, 1 over a millionth. Very, very close to 0 on the positive side. When we come over to the y values, the reciprocal values, we're going to flip that. So 1 over positive a million is going to become positive a million. And we can translate positive a million to positive infinity. So on a reciprocal graph, as the x value moves closer and closer to 0, our y values on the reciprocal graph are going to head towards positive a million, otherwise known as positive infinity. So I'm going to put that little arrow there, and later when we draw our graph, it's going to include that arrow right there. Okay, now let's approach x equals 0 from the right side. Okay, what's happening? Down here we're at negative 100, now negative 10, negative 1/10. Eventually we're approaching 0. We're going to have negative 1 millionth. Okay, I'm going to put the negative down below. When we come over to the reciprocal side, we're going to flip that. Instead of 1 over negative a million, we're going to have negative a million over a 1. And what does that translate to? Negative infinity. So we come to our graph. As x approaches 0 from the right side, the reciprocal graph is going to approach negative infinity. We indicate it with that arrow there. Folks, we're going to do the same thing with the other 0 on the original graph. Okay, let's approach that 0, which is about x equals 4, from the left. As we approach from the left, what are our y values doing? Here we're at negative 100, negative 10, negative 1. Now we're into fractions, negative 1 millionth. I'm going to put that as 1 over negative a million. Okay, when we flip that to the reciprocal, we're going to get negative a million, and I'm going to call that negative infinity. So as you approach the x equals 4 from the left, you're going to be at negative 1 millionth. As you approach our graph on the right, as you approach that point right there, x equals 4 from the left, we're going to head towards negative a million. Finally, we're going to approach the 0 on the original graph from the right. What are our values doing? They're getting very, very small positive. Here we're at positive 100, positive 10. Now we're in the fractions, 1/10, 100th. We're at positive 1 million right there. That positive 1 over a million, 1 over positive a million right there, 1 millionth. We're going to flip that. We're going to get positive a million, and we're going to put that on this graph. So as we approach that point from the right on the original graph, we have this tiny, tiny small fraction, positive, that turns into a big, big, big positive infinity, as so. Okay, now we're going to look at end behavior. End behavior is what's happening to the graph as x approaches negative infinity, way over here on this end, and as x approaches positive infinity, way over on this end. So let's look at our original graph. As x approaches positive infinity, our graph is approaching positive infinity. The y values approaching positive infinity. So let's indicate positive infinity as positive a million. Okay, so your graph is going to go, here are y values about positive 100. Here it's positive 1,000. It's heading towards positive a million. What's going to happen on the left end of our reciprocal graph? It's going to be the reciprocal of that. So as we move to the left, our graph is going to be at 1 over 100. Then we're going to go further, 1 over 1,000, 1 over a million. We're approaching 0. Positive 1 millionth means we are at approaching 0 from the positive side. Here, we're going to do the end behavior of our graph as x approaches positive infinity. Folks, our original graph is doing the same thing. It's approaching positive infinity. That means on our reciprocal graph, it's going to approach 0 from the positive side. Okay, one last thing. I want to take this point and I want to convert that or plot the point on our reciprocal graph. So let's just pick points here. Let's call this 2, -5. All right. As we move to our graph here, the 2 stays the same. The -5 flips. We're going to have 2, -1/5. I'm going to put that right here, right next to the x-axis, which is 0. So 2, -1/5. All right. I think we have now enough to sketch this graph. Let's go ahead and do that. We know that our graph has to come through this invariant point. We know it's headed towards towards 0 from the positive side. We know it's heading towards positive infinity. Folks, we're just going to connect these points, these arrows, like so. Okay, so the graph is going to look like this. Okay, in this section here, we know our graph is going to encompass the arrows. We know it's going to hit these 3 points. So we got this going on. And finally, the graph is going to be over here, connecting arrows and that invariant point, and this is our tentative sketch. Folks, we have our sketch of our reciprocal function. Let's do some confirmatory analysis. Folks, if you have a positive number, let's say positive 5/1, and you take the reciprocal of that, you're going to have positive 1/5. Meaning, if you are positive, your y value is positive on the original graph, it's going to stay positive on the reciprocal graph. So let's see if our graph meets that challenge. Here, our graph is above the x-axis. All these values are positive until you hit x = 0, the origin. Look at our graph. All these values are above the y-axis. Here, all of our values are negative. The same argument applies for a negative number. If you have -3/1 and you flip that, you still are going to have a negative number. Folks, here on our original graph, all these numbers are this region, our y values are all negative. In between 0 and x = 4. Here we are, between 0 and x = 4, all the y values are negative. Perfect. Finally, the last section to the right of x = 4, this zone, positive, positive. So this graph meets that criteria. One last confirmatory analysis. Where is this graph increasing and decreasing? The original increasing, and I'm going to abbreviate that, decreasing. And where is this graph increasing and decreasing? These should be the opposite. So let's look at what our graph is doing. Remember, when you look at a function and you're trying to determine is it increasing and decreasing, you ignore these arrows here. We know this function continues to go up in this direction. We know it goes up in this direction. We ignore those when we're figuring out increasing or decreasing. What we do is we simply go left to right and we evaluate what the y values are doing. Okay, so here we're going to hop on the graph here. We're going to ignore that arrow. We're going to head left to right on the x-axis, but we have to stay on the graph. What are our y values doing as we're heading left to right? What are our y values doing? They're decreasing all the way up until x = +2. So the original graph, let's erase this. Our original graph on the x interval from -∞ all the way to +2. In this interval, our original graph, the y values are decreasing. All right, let's now jump to that same interval from -∞ to +2 on our reciprocal function. Here we are, we're jumping on the graph. Our y values, as we're moving left to right, what are they doing? They're increasing. We're going to jump off, we're going to get back on the graph. We're going to ignore that arrow. We ignore that. We're heading towards the right. Our x value will always go left to right. We're heading left to right. What are our y values? They are increasing. So here on the reciprocal graph from negative infinity all the way up to positive 2, the graph is increasing, the exact opposite of what we saw on the original graph. Finally, let's look at the interval from positive 2 to positive infinity on the original graph. We get on the graph here at x equals positive 2. We head to the right. As we head to the right, what are our y values doing? They are increasing. So on this segment from positive 2 to positive infinity, the original graph is increasing. And here, when we look at our reciprocal graph, we're going to jump on at x equals 2. As we move left to right, what are the y values? They're decreasing. We get back on the graph. We ignore that arrow. We get back on the graph. We're moving left to right. What are the y values doing? They are decreasing. So the exact opposite from the original function.